Innovation pays off.
My bad, my bad. I'm really very sorry, guys. There was a technical glitch over here. Am I audible again? My bad, my bad. I'm really very sorry, guys. There was a technical glitch over here. Am I audible, guys? Once again, ping me up again. Am I audible again? Okay. My bad, my bad. I'm really very sorry, guys. Again, and I'm really very sorry for this technical glitch over here. This session is basically all about aeromodelling, aerodynamics, how aircraft work, how drones work, ping me up again. कैसे बनाते हैं, how do we make aircraft? Am I audible again? And all those stuff, all those fantastic stuff had to be like taken care of. So the thing is, why we have started this session, right? The प्रॉब्लम क्या हो रही है कोविड-19 में कि एवरीबॉडी इज स्टक एट होम माय बैड आई एम रियली वेरी सॉरी गाइस एंड आई एम रियली वेरी सॉरी फॉर द टेक्निकल ग्लिच ओवर हियर एनी काइंड ऑफ दिस सेशन इज बेसिकally all about aeromodelling guys aerodynamics how aircraft work how once again ping me up again कैसे बनाते हैं how do we make aircraft audible again all those fantastic stuff share knowledge to be like taken care of and everybody can take benefits apart from why we started this students of fire robotics lab प्रॉब्लम क्या हो रही है कोविड-19 में कि एवरीबॉडी इज स्टक एट होम माय बैड आई एम रियली वेरी सॉरी गाइस एंड आई एम रियली वेरी सॉरी फॉर द टेक्निकल ग्लिच ओवर हियर एनी काइंड ऑफ दिस सेशन इज बेसिकली ऑल अबाउट aeromodelling guys aerodynamics how aircraft work how once again ping me up again कैसे बनाते हैं how do we make aircraft Is it good now? Double audio. Is it fine? Echo is gone? Absolutely, apologies. Please accept my apologies. We have of this technical problem. Some systems are new, so they are taking a little bit of time. Okay, is it still echoing right now? Is it good or is it echoing? Just tell me once more time. One more time, please. Okay. Yes, no, no echo, no echo. Okay. Okay, I suppose. Okay, fine. Okay. So, like we have wasted a lot of time on technical glitches. So we are moving forward. कि आज का session क्या है and what we are going to learn and what will be all those coming sessions all about, right? So this short course number 1 that is based on aeromodelling is beginning from today, and we will be taking sessions in TTS, that stands for Tuesday, Thursday, and Saturdays. Okay, and this session had been designed in such a way that you can perform practicals, you can share your practicals, you can share assignments with everybody so that everybody can see what your progress is all about. We can see what you have learned in this session, and moreover, we can evaluate you, like what you have grabbed from this session and how much you are taking benefits from this. So we'll acknowledge your feedback, we will acknowledge your projects, what you'll be doing in this particular sessions, and after this we'll be taking your test. On the base of test, there would be a lot of stuff. You'll be getting internship opportunity, you'll be getting some free goodies, you'll be getting some certificates of merit and participation as well. So I'll be discussing all those stuff in the slides coming up. So let's get started, guys, without wasting any further time. Okay, let's do it. Okay, are you guys able to see the PPT? Let me check again once the YouTube channel too. Okay, we are good. So this is Phys Robotics Channel's tutorial, season 1 of Aeromodelling. So these are the lessons what you'll be covering in next 7 lectures. Today would be basics of aerodynamics. Second, that will be on Saturday, would be understanding forces with airplanes. You will be making few airplanes at home. I'll be letting you know what exactly you have to do and how you have to do. And third lesson that will be on Tuesday will be about design analysis of types of aircrafts, then making your own aircrafts at home, procedure to fly an aircraft and understanding the maneuverability. Sixth would be what skills do you require to be a pilot. Okay, and the 7th session that would be a live question answer session and troubleshooting or doubts clearing session live on directly YouTube. You can have a comment section, you can put down your comments in the comment section, and we can see and we can respond accordingly in the video itself. And 8th would be a date where we'll be taking your certification test. Okay, so this is a table of content. We are beginning from today, that is Thursday. Then next class would be on Saturday, then Tuesday, Thursday, and Saturday. Same TTS pattern would be followed. Okay. Next. So basics of aero modeling. Okay, about aerodynamics and short series course. अब कितने लोगों को ये exactly पता है what is aerodynamics all about, right? There are two words here. You can see first is aero and the second one is dynamics, right? Dynamics stands for motion. आप motion की study जिस चीज में करते हैं that is called dynamics. And aero stands for particularly air, the things related to air. That is the total word as aerodynamics. So aero plus dynamics, that stands for air plus dynamic motion, is known as aerodynamics. Okay. So what does exactly aerodynamic mean? The meaning of aerodynamic is the study of properties of air with respect to solid objects interacting with it. If you can see the example, there is a hummingbird over there, and you can see the second definition too. Aerodynamics is the study of forces and resulting motion of objects through air. अब मैं इसको exactly आपको समझाने की कोशिश करता हूँ कि इसका मतलब क्या है and what exactly ये कहना क्या चाह रहा है, right? What is the definition and what does exactly it mean? जब भी कोई ऑब्जेक्ट हवा के साथ कांटेक्ट करता है या हवा के साथ इंटरेक्ट करता है, सो कुछ चेंजेस होते हैं, कुछ फोर्सेस में चेंजेस होते हैं, कुछ प्रेशर में चेंजेस होते हैं, कुछ अलग अलग फिजिकल प्रॉपर्टीज चेंज होती है, राइट? अब वहाँ पे बहुत सारे फैक्टर्स काम करते हैं कि बॉडी कोलैप्स हो रही है, बॉडी पे कितना प्रेशर पड़ रहा है, बॉडी में डेंट्स आ रहे हैं, कि बॉडी वहाँ पे ग्लाइड कर रही है, बॉडी इज फ्लोटिंग, मैटर इज फ्लोटिंग और सम ऑब्जेक्ट इज फ्लाइंग ऑन टू दैट पर्टिकुलर स्टफ. सो उस चीज़ को एनालाइज करना, उसका रिजल्ट निकालना, उसको डिजाइन इम्प्लीमेंटेशंस में यूज करना, दैट्स ऑल फैक्टर्स कम्स अंडर द पार्ट ऑफ एरोडायनेमिक्स. सो इट्स बेसिकली ए स्टडी ऑफ प्रॉपर्टीज ऑफ एयर जो इंटरेक्ट करती है सॉलिड के साथ. जितने भी एयर की प्रॉपर्टीज है, लाइक फ्लो है एयर की प्रॉपर्टी, एक प्रेशर है, प्रेशर ग्रेडियंट एयर की प्रॉपर्टी होती है, राइट? एंड फ्लूइडिटी एयर की एक प्रॉपर्टी होती है, टर्बुलेंस होता है, लैमिनार फ्लोज होता है, टाइप ऑफ फ्लोज होते हैं बहुत सारे, राइट? सो दिस इज बेसिकली स्टडी कि ये चीज़ें कैसे काम करती हैं और एयर से इंटरेक्ट करने के बाद एक बॉडी किस तरीके से रिएक्ट करती है. दैट ऑल कम्स अंडर अ पार्ट ऑफ एरोडायनेमिक्स, राइट? सो इफ यू कैन सी दिस हमिंग बर्ड एंड इफ यू सी द रोबोट beside it, you can see the pattern in simulation how they are mimicking the motion of hummingbird through robotics. So this is basically happening and possible just because of slow motion cameras and studying the pattern at which it is behaving on air, so that we can replicate that on the term of animatronics and we can build animals through that particular inspiration, right? So this is the part of aerodynamics. We'll be discussing about, okay, let me put my video a little bit downside. Okay. Now is it visible? So few people are having some difficulty in understanding in Hindi, so we'll stick to English as per now. And in Q&A session, we'll try to be multiple language support, right? So now the term comes, what is aeromodelling? Again, aero stands for air, modeling stands for you're building something out of scratch. You are making any model, a representica or any kind of prototype that is representing some factors or an idea is called the process of modeling. So aero plus modeling stands for building some objects that works on a motion of air. That is called aeromodelling, right? So if you can see this image, you can see that two students are making a wing of an aircraft. They are the students of Fire Robotics Lab, JPS Noida, right? So the basic definition of aeromodelling is an activity involving design development, flying of a small air vehicles. Right. It is an interesting way of learning, understanding engineering principles, as designing of an aero model is high based upon it. So exactly like this is want to say it. You will be making some air vehicles. You will be making some aircrafts. You will be making some airplanes. You will be making some vehicles that would be able to interact with air, can fly in the air, and all those particular stuff in aero modeling. So aero modeling is basically a sort of hobby branch where you study and make small prototypes of air vehicles such as quadcopters, drones, aircrafts, and airplanes. So this is all about aeromodeling, right? So moving further, laws and principles which are governing aerodynamics and aeromodeling. So before discussing this, I'll let you know, like I'll give 10 minutes of time to everybody to interact with me after this particular presentation is over, so that we can interact and have some Q&A session just after the video. If you have some doubts, I can clarify it right on the video itself. Okay. So the laws and principles what are governing aerodynamics and aeromodeling. First law is the third law of motion. There was a scientist called Isaac Newton. I hope you guys are all aware, the small kids, those who are watching this video might be aware. Like there was a story from a tree, some scientist was sitting beneath a tree and an apple fallen on his head, and he started driving some equations. He founded the term called gravity force. So the name of the scientist was Isaac Newton. So he gave 3 laws of motion, out of which third one is very important as a term of aerodynamic and a part of aerodynamic, right? So the third law states that for every action, there is an equal and opposite reaction. So let us understand what exactly it means. For example, if you can see the walls behind me, simple example I'm giving you of third motion. If I start pushing that wall, right? Will anything happen? Will anything happen onto me, or will anything happen onto the wall? Will I be able to push the wall? No. Until unless I am the Hulk of Avengers, right? So there will be no motion. You cannot see that motion happening with your naked eyes. But in reality, what is happening is I'm applying force, moving force on the wall, and wall is applying a reverse force of same amplitude on my body, on my hands. I can feel that force on my hand, right? My hand will be squeezing on the walls, but I won't be able to like move it further just because of its mass and weight, right? But when I try this experiment, for example, with my water bottle, if I'm trying to move this water bottle like this, I'm able to do it, right? Because of it does not have a lot of mass, it does not have a lot of weight compared to the power I have in my hand, right? So this is like what is happening. If you imagine the bottle, when I'm pushing the bottle, it is applying some force on my hand, but I'm not able to feel it just because it does not have that required force to give a feeling that I'm getting hurt on my body. On the case of wall, I'm getting a little bit squeezing on my hand because the wall is applying a reverse pressure on my hand. So this is the third law, which states whenever you apply a force on some body, whether you can see it or whether you can feel it, whether you can feel or we cannot feel or see it, still that body would be applying a reverse pressure of force in opposite direction equal to the amount of force you are applying on it. To perform this practical, there is a like very good example at home. You can try this to understand about this third law of motion. Come running, right? Come running at little bit of speed and try to push the wall. You will hear a sound, a bump sound on the wall, and you'll feel like you have moved a little like little bit of centimeters in the wall. But at reality, it would not be happening. But if you see your hands, there would be a redness on your hand. Just because the same amount of pressure what you applied to the wall just get back transferred to your hand by the wall. This is called the third law of motion. Like whatever force you're applying on the body would be directly applicable to you on your motion of the object, what you are implying to it, right? So this law of motion was given by Sir Isaac Newton, or you can call him at funny stick Newton Chacha, right? There is a second principle given by a very good mathematician, or very best mathematician renowned in physics. He is known as Mr. Daniel Bernoulli, right? He had given a principle in fluid dynamics, or you can also known as the principle. If you can search it on Google or on the web, you'll find that it's called as Bernoulli's fluid principle or Bernoulli's principle. That is applicable mostly on aerodynamics and aircraft flying mechanisms, right? So the law states that if the speed of a fluid increases, the pressure decreases, right? So to understand this statement, what does it trying to say is, First, we want to know what is fluid all about. Fluid can be liquid. There are different types of fluid. I'll let you know what exactly fluid means, what is it meaning, and how does it work. Right? I'll let you know at the end of the video. But to understand what this fluid is, you can say any object or a substance that has a tendency to flow in given certain pressure and amount. That is called fluid. For example, water. For example, sanitizers. Right? For example, any kind of gases that comes under the category of fluid that has a tendency to flow without any restriction. That is called fluid. Right? It does not have a fixed shape or size. It can go anywhere under any pressure. It changes its form. So it does not have a fixed shape and size, and it can flow to any surface. Right? That is called a fluid. So the Bernoulli said, if the speed of a fluid increases, the pressure exerted by the fluid decreases directly. To understand this example, you can perform a very good practical at home. This one. Experiment number 1. You might have seen in arcade areas, in arcade plays or in the malls, there is equipment where a ball is hovering over a pipe which is flowing a very good amount of air onto it. We do a lot of games and practical. We have seen in movies, we have seen in a lot of kiddie games, like we have to blow a ping pong ball above a pipe and we have to keep it hover like on the ball. So what exactly the principle behind is, I'll tell you on a later stage, but this is an application of Bernoulli, and this is the application of Bernoulli's principle, right? So what is happening is, for example, if you go for a car wash, or if you wash your bicycle or wash your bikes with a pipe having fluid in it, having water in it, if you observe that particular fluid, what happens is, when you are just pouring the water through that nozzle, through the opening of the pipe, you will see a greater density of water coming out, right? But having a certain amount of speed. But what happens is, when you apply pressure on the opening and you try to reduce the opening surface area, what happens is the fluids start to flow at a very great speed, right? The speed increases, but the resultant pressure at the body, what was pouring onto it, gets reductively decreases. So this is the Bernoulli's theorem or the Bernoulli's fluid principle. If a speed of a fluid increases, the pressure of the resultant fluid decreases. I'll give you another experiment to perform. This is also this experiment number 1 is also known as Venturi's experiment, right? Venturi's had given an application on Venturi meter. You can Google it. That the term is Venturi meter, right? There was another scientist named as Venturi, Mr. Venturi. He had given an experiment on Bernoulli's principle of fluid. So what is happening is, if you can see this ball, the first figure, when the air is flowing towards the ball from all the directions equally, the ball is resting in the mid of the pipe. It's not going anywhere else. But what happens is, if you make sudden jerk movement in the ball with respect to the pipe, right, and if you shift here, or if it shift left or right in any direction, what is happening is, the amount of air from the gap gets higher, apart from as comparatively on the top of the edge it gets lower. So what happens is, where the air is moving fast, the pressure in that particular area becomes low, and where the air is moving really very slow, that particular area becomes a high pressure zone. So there is a tendency in the objects, there is a law in the nature, like always high pressure zone flows from any objects from high pressure zone flows to low pressure zone. There is never a reverse flow of low pressure zone to high pressure zone without using any external equipment like motors or pumps. There is a very good example to understand this part is symphony, or the siphon system. When you have seen two containers, there would be if you imagine there is 1 meter container having full water, and there is another container of 0.2 meter, it does not have any water present into it. If you put a pipe and exert a suction pressure in that particular tub or in that particular 1 meter tall container, water starts to flow from that region and come down to that smaller container. This is called the siphon system. It works on higher pressure zone to lower pressure zone. This is the best example of high pressure zone and low pressure zone. This is the same principle behind the wind flow. Why does the wind flow? Why we experience cyclones? This is the key concept of that particular principle, right? So if you can see the figure number 2, what is happening is where the air is moving very fast, there is a low pressure zone created, and where the air is flowing very slowly, going round the way to the top of the ball, the pressure gets high. So what happens is from high pressure zone to low pressure zone, the balls will travel from right to left according to my hand, right? Right to left. It will go like this. But what happens is if the ball is going little bit left hand side, so the stream of air will be flowing high flowing air would be from right hand side. So what will happen is it will be a high pressure zone at left hand side. It will push the ball and to the right hand side of my hand, right? So the basically to understand this principle to the smaller kids who are watching this video, I'll like give you this experiment as a part of your activity to perform today, and get back to me on the chat section after performing this particular thing, and put down your comments like what exactly you feel after experimenting this particular practical, right? And people who cannot blow air continuously with their lungs, they have limited lung capacity, or if you have any problem in breathing, you can always use your hair dryer or the blowers available at homes, right? So that is the same concept. What is the task would be? Your challenging task would be to keep that ball in the mid of that blower, right? To perform successfully the Bernoulli's principles experiment. So this is your activity number 1 for today, that you have to perform this experiment using your lungs or using your artificial blowers or hair dryers, right? So moving further, yes, this is very important question. Question number 3, what are fluids? Many people would be asking or thinking what exactly the fluids is, right? Okay, till then we have no questions. Okay, let's go back to our presentation. Please speak in Hindi also. Ma'am, there are some people who are not able to understand Hindi, so I'll give a bilingual act, right? So let's start with what is fluids. Fluids क्या होते हैं, right? या जिसे हम हिंदी में बोलते हैं द्रव्य पदार्थ क्या होते हैं. What are fluids? या तरल पदार्थ या द्रव्य पदार्थ. हिंदी में इनको तरल बोला जाता है. जैसे कि मैंने आपको पहले भी बताया था, what I've told you before, a substance that has a tendency to flow. किसी भी substance में या किसी भी matter में, right, एक physical property होती है जिसको हम बोलते हैं tendency to flow, बहने की, बहाव की property होती है. That बहाव की property is called as the flowing tendency in English, right? For English speakers, the statement is like a substance or a matter that has a tendency to flow in any kind of environment is called fluid, right? Fluids वो तरल पदार्थ हैं या तरल पदार्थ वो सब पदार्थ होते हैं जिनके अंदर एक फिजिकल प्रॉपर्टी होती है, जिनके अंदर एक खूबी होती है बहने की, बहाव देखने की या बहाव को समझने की क्षमता, या एक उनकी इंटरनल प्रॉपर्टी इसको आप बोल सकते हैं जो बहती है. दैट इज कॉल्ड फ्लूइड्स. For example, gas, for example, any kind of liquid, for example, any kind of sanitizers, right? Oxygen, air, ये सारे के सारे fluids हैं. अब fluids के दो major examples होते हैं. First one is liquid, right? You can feel liquid. आप liquids को feel कर सकते हैं. तरल को आप feel कर सकते हैं properly. जो द्रव्य पदार्थ हैं उनको आप feel कर सकते हैं. That is called liquids. For example, आप water को हाथ में लेते हैं, so you get a sensation feeling that you are getting wet. That feelings, that neuron firing tells you that you have substance in your hand that is wet, that has a tendency for making your hand wet, right? So, for example, air. आप हवा को जनरली महसूस नहीं कर सकते until unless वो एक हाई प्रेशर एरिया से आपकी तरफ आ रही हो या एक लो प्रेशर एरिया से आपकी तरफ आ रही हो, राइट जब तक वो आपके चेहरे पे नहीं पड़ रही है, जब तक आपको बहुत तेज इंपैक्ट नहीं कर रही, until unless you cannot feel the air, but still it is flowing. We cannot see it by naked eyes, but if you want to feel air, how air is flowing, you can just take an example of agarbatti, right? Everybody is having a candle or an agarbatti at home. When you light it up, the stick candle, when you light it up, there is a fumes coming out. You can see that fumes, or you can see that particular molecules of that substance coming out and having a tendency of flowing upward due to its lighter weight. That is called the tendency to flow. Second example is a substance that has no fixed shape and size and can easily deform under pressure. इसका सबसे अच्छा एग्जाम्पल मैं आपको दिखाता हूँ. लाइक आई हैव अ सैनिटाइजर. मेरे पास एक सैनिटाइजर है. ये सेकंड स्टेटमेंट आपको इससे समझ में आएगी. यदि मैं अपने हाथ पे एक सैनिटाइजर की थोड़ी सी बूंद लेता हूँ, राइट, मैं उसके ऊपर प्रेशर अप्लाई कर सकता हूँ. It can deform, it can spread into my hand, right? It can spread into my forward, back arm, forearm, anything, wherever I want. But if, for example, my mobile phone, if I'm having a pressure, can I like deform it? No. Can I like keep it this one, that one? I can rub it. I cannot do it because it's a solid structure. It cannot flow. It does not have a tendency to bifurcate. It does not have a tendency to deform. उसके अंदर ये खूबी नहीं होती कि वो फैल सके, वो अपने आप को एक्सपैंड कर सके. लेकिन लिक्विड्स में और फ्लूइड्स में एक बहुत अच्छी प्रॉपर्टी होती है कि आप उसे किसी भी कंटेनर में डालो, वो उसका आकार ले लेता है, उसका शेप एक्वायर कर लेता है वो जिस कंटेनर में जाता है. सो इट कैन डिफॉर्म इजिली अंडर प्रेशर. दैट इज कॉल्ड फ्लूइड्स, राइट. This is a very great example of water in the space. If you can see this example. This is your second activity. The question for the second activity for today's session is, let me know your feedback and your research, whatever you can find on net, like why this liquid is behaving like a sphere, right? Why ये liquid जो है, ये जो water का droplet है, ये इतना बड़ा क्यों है, ये फैल क्यों नहीं रहा, और ये एकदम spherical क्यों बन रहा है स्पेस में जहां पे ग्रेविटी फोर्सेस नहीं होती, वेयर देयर इज जीरो ग्रेविटी. व्हाई दिस liquid bubble is taking, this water bubble is taking a spherical shape in the space. So this is your activity number 2 for today, right? So first activity was to perform that experiment number 1 and 2. Second activity is to find the answer why this particular bubble is taking a spherical shape in space. So this will solve and give you an understanding how fluid works. What are the forces behind this fluid, right? So this is it for today. This is very basic and general introduction for today's session. आज का सेशन हम यहीं रोकते हैं. I'll give you 5 to 10 minutes. If you have any questions, any doubts regarding this, just let me know. And make sure you always perform your activities. Keep a vital record of it. Keep videos of your activities and upload to your drives, upload to your Google Drives. आप उसे Google Drives पे upload कीजिए and send it back to us at contact@fizzrobotics.com, right? With the title as assignment number 1, so that we can have a record with you, and while evaluating your performance, we can keep that record with us. So thank you everybody for listening, and sorry for the glitches that has come at the beginning of this session. And now I'm giving you 5 to 10 minutes of time to comment your questions on the comment box, not on the live chat, so that everybody can see it after the video is over, right? So you have to submit your assignment by tomorrow midnight on contact@fizzrobotics.com, and don't forget to give your details like your name, your class, your section, your school, and your location, so that we can see how many people have taken benefit out of this particular experiment. So happy learning, guys. Stay safe and come back to comment section so that we can solve your queries. Thank you so much. Guys, if you have any queries, feel free to ask me. Put all your questions once again in the comment section, not on the live chat, so that I can see it right now. Okay, guys? Put all your queries on the comment section. Because of gravity, fancy guitarist. Okay. Uh, we'll discuss this in next session on Saturday. I can see this is not a fake video, guys. This is recorded in International Space Station. Super Smarty DC is correct. The next class would be on Saturday. Okay, Krishna ji. TTS. We'll be following TTS pattern. Tuesday, Thursday, and Saturday. Can we say fluid is a mixture of gases and liquid? No, dear. Fluid cannot be a mixture of gases and liquids both. Fluid has a characteristics or a difference. Like there are two types of fluid. First one is liquid and other one is gas. There are a lot of categories onto it. Compressible fluids, non-compressible fluid, Newtonian fluids, non-Newtonian fluids. So if you want to know about fluids, just let me know. I'll make a complete video on the fluids, like what are fluids, how does fluid works, and कितने types के होते हैं, कैसे कैसे काम करते हैं, क्या क्या environment होता है. But yes, fluid cannot be a mixture of any gas or any kind of liquid altogether. They have a very different tendency and different characteristics, right? If you have any like explicit example where you have seen fluid and gases, like liquid and gases all together as fluid, just comment down below so that I can know. Okay. You can see some fluids where a solid mixture is mixed with liquids to make a fluid that are non-Newtonian fluids or Newtonian fluids. I'll give you an example in coming sessions like what exactly those are. But they cannot be a combination of gases and liquids. I hope Kishwar get to this particular question, and if you have any further questions, just put it through. Okay, guys, let's move on to next one. Okay, today's assignment is you have to perform those two practicals, right? And the second one was to find the answer and the forces behind that particular video you have seen from International Space Station. जो आपने वो वीडियो देखी थी एक ड्रॉपलेट की पानी के, वो ऐसा क्यों बिहेव कर रही है स्पेस में विदाउट ग्रेविटी. आई नीड दैट आंसर, ऐसा क्यों हो रहा है. एंड the first assignment was to perform that practical and shoot your video. I need 5 to 10 seconds of balance ping pong ball in the mid of your blowing pipes or your hair dryers. Okay, so these are two experiments that you have to perform, and by tomorrow midnight you have to send both the videos with your name, school name, your class details on contact@physroboticsolutions so that we can evaluate that particular assignment on like after your exams, right? After your test has completed, the final test for this session. Okay, Sanya Tripathi, sir, please explain aeromodelling once again. Okay, बेटा aeromodelling में दो words है. पहला है aero and second one is modeling. Aero का मतलब होता है air. Aero stands for air. That means something related to air, right? जिसमें एयर का बहुत इंपॉर्टेंट पार्ट है. द सेकेंड वन इज मॉडलिंग. मॉडलिंग का मतलब ये होता है कि आपके पास यदि कोई भी आइडिया है, राइट, इफ यू हैव एनी आइडिया ऑफ मेकिंग अ ड्रोन, इफ यू हैव एनी आइडिया ऑफ मेकिंग एयरक्राफ्ट, इफ यू हैव आइडिया ऑफ मेकिंग एन हमिंग बर्ड और एन ऑर्निकॉप्टर लाइक एन मूव इन उरी, राइट. सो मॉडल बनाने का मतलब क्या होता है कि यू आर कन्वर्टिंग योर आइडियाज, योर इमेजिनेशन इनटू अ फिजिकल फॉर्म. that is called modeling or project making. So combining those two words, aero plus modeling, means making some vehicles, making some projects that has a working related to air, that can work in air, in presence of air, that is called aeromodelling. राइट, आई होप आई हैव मेड यू क्लियर. मैं आपको हिंदी में एक बार बता देता हूँ. एरो मॉडलिंग का मतलब है कि आप ऐसे प्रोजेक्ट्स बना रहे हो जो एयर के प्रिंसिपल्स पे वर्क करते हो, एयर के प्रेजेंस में वर्क करते हो, या एयर की प्रॉपर्टीज के साथ काम करते हो. दैट प्रोजेक्ट्स एंड दैट पर्टिकुलर प्रोसेस, वो सारी प्रोसेस को हम एक वर्ड में बोलते हैं एरो मॉडलिंग. ओके, असाइनमेंट आई हैव ऑलरेडी गिवन. ओके, यू कैन नॉट अंडरस्टैंड एक्सपेरिमेंट 1. NIPG. Okay. Experiment 1 is all about making a video of yourself balancing that ping pong ball on a dryer or on a pipe, blowing air from your mouth. And that is a very fun-loving game to understand Bernoulli principle, and try to disbalance the ball and try to balance it again so that you can understand the flow of air through the ball. So you have to perform that experiment of blowing that air. Rewind this video after this had been published and you can see the images again. Perform that particular experiment, shoot that video and send both the videos to contact@physrobotics.com by tomorrow midnight with all your details mentioned on it. Okay? Okay, so please tell us something about you, Sakshi. Okay, I am Vaibhav. I'm trainer of Phys Robotics Solution. I have a hobby of flying drones, making aircrafts, making robots, fun-loving projects, teaching my students how to build those things, and basically I'm an entrepreneur also. So mixed kind of stuff. I'm totally a mixed veg. So you can enjoy me in the sessions. So you'll be knowing more about me. Okay. So that is all about me and my company. Okay. Sir, can you show the video again? You can see the video after the session has been ended. It will be available on YouTube in the same link. You can just rewind it and see the presentation again. Okay? Sir, how can I talk to you personally? Contact@physrobotics.com. That is the key to contact me. Okay, I want to make a drone. Yes, you can make a drone. We'll be discussing how to build a drone at the end of the sessions. Can we use a paper ball? Yes, you can use a paper ball, but it should be covered in tape. It should be covered in tape, so there should be a lot less amount of resistance. आप paper balls को भी use कर सकते हैं, but make sure it is taped well so that the surface is clean. Okay? Sir, our lungs gonna die. Make your lungs bigger then. What can I do, Mr. Anonymous? Sharda Pant, how fluids and aerodynamics related? Aerodynamics is not possible without fluids, without air. Because in aerodynamics, there are a lot of things. When I'll show you the simulations of vehicles, जब हम किसी व्हीकल को डिज़ाइन करते हैं तो उसमें फ्लूइड्स का क्या काम होता है, वहाँ पे लिक्विड्स कैसे ऐड करते हैं, वहाँ पे एयर कैसे ऐड करते हैं. I'll tell you brief about that. It was just an introduction so that people does not get confused with fluids and air. These are both different things. I just made it clear, made it a point so that everybody can get a clear perspective of this. What are the difference between fluids and this thing, your air part, right? Okay, sir, please something about you. I have already told you. I am from Alpine Khurja NIPG. Welcome NIPG, and motivate all other students whom I have failed to reach and tell them to join the Alpine group on our Facebook page. There is an exclusive page for all our clients named JPS Robotics or Alpine Khurja or Monastic, everybody. Sir, I am from Jharkhand Public School, Noida. Difference between pressure and stress, Aditya Garg. That would be covering up in the next session, dear. Pressure and stress and all the forces after the practical you have performed and giving me the explanation on the video. So that is for today, guys. Let's wrap this session up. I hope you have enjoyed this particular session. And the next session, you already know I have given you the index in the presentation, so you can just view the index again. And we'll continue on Saturday at the same time, 12 p.m. And if you have any queries, if you want to interact me with you, just comment down your questions below in the comment section after this live video is ended, because live chat would not be available after the video is ended. So make sure you put your comments down on the comment section if you have any doubts. If you're new to our channel, subscribe our channel for the latest updates. Keep it yourself tuned, and I'm really very sorry for the technical glitch that has occurred in the starting of the session. I hope it would not occur again. I'll give my best to the next session. So that's all for today. Have a great day, guys. Stay safe. Start doing practical. Keep innovating your projects. And let me know your ideas if you're performing any kind of other than practicals apart from these sessions. I'll be loving it to help you out, guys. Thank you, everybody. Thank you for coming up. And subscribe to the channel for the latest updates. Thank you so much. Stay safe, guys. And I'll hope you'll send your project videos on contact@fizzrobotics.com. Cheerio, guys. Take care and goodbye.